All right, let's get started with our unit test of probability and combinatorics in the course of Precalculus. All right, so we have in total 12 questions. For the first question, Cora is playing a game that involves flipping three coins at once. Okay, you have got three coins that you will flip at once. And let the random variable h be the number of coins that land showing heads. Here is the probability distribution for h. So h equals number of heads. That if the number of heads is 0, this is the probability, and so on and so forth for 1, 2, and 3. Now we need to find the probability for that. There we have head on 2 or more than that, greater than equal to 2. So that means that it includes these two. Okay, so for probability age is greater than or equal to 2, we simply add these two things. So we have 0.375, so 0.375, and then we have 0.125, so 0.125. We add them, 0.5, so our answer should be 0.5. Yep. All right. Second question. Marcos and Amaya work at a mobile phone company that offers customers an optional care plan. All right. Customers can choose to pay an extra $50 when they buy a new phone, and if they damage their screen, then the company will cover the cost of the repair. All right. Marcos and Amaya let X represent their company's net gain on the sale of a given care plan, and they find the expected value of X is EX equals to $25. Marcos says, okay, if we sell many of these care plans, the average gain for our company will be about $25 per plan. This is what Marcos says. Amaya says for every 1,000 customers who buy this plan, we can expect a net gain of, okay, because we have an expected value of 25 for selling each at 50. So 25 times 1,000 is 25,000. Because you're selling each at 50, so 100,000 multiplied by 50. So this thing, subtracted this thing, actually equals to 25,000. And I think both of them are correct. Both statements are correct because this is what the average gain is for the company, because the expected value of X represents the average gain. So when you take $50 from each customer and you get an expected value of 25, so which means um, 25 is your gain. So C should be our correct answer. There we go. For the third question, Pedro is designing a board game where players roll two six-sided dice. Okay, so we have six-sided dice, two of them. So here's one, here's one. So he's designing a board game where you will where players will roll two six-sided dice and subtract the numbers showing on the face. Let's say if one is six, another one is two, six minus two, four, something like this. The game only looks at non-negative differences. Okay. For example, if a player rolls a 4 and 6, the difference is 2, not 4 minus 6 minus 2. This is not what we're looking for. We're looking for non negative differences. All right, so Petro simulated the differences of 500 rolls. Fill in the blanks to complete the probability distribution table. Do not round your answer. So, difference 0, frequency 88, probability is 0 point. Okay, so we have 500 rolls, right? So which means all of these must add up to 500. So similarly, the missing value that we want here would be 500 minus 88, just the missing values. So 500 minus 88, then we have 134, negative 134. Then we also have 86, 56, negative 86, negative 56, and we have 26, negative 26. So 110. This is the frequency. I'm going to put it later after I find the probability as well. And we know that the summation of probability is 1. So this thing will be equal to 1 minus all of these values, which is um, 0.176. So 0.176, negative 0.268, 0.268, negative 0.172, negative 0.112, 0.112, negative 0.052, 0.052. So 110 and 0.22 should be our answer. 110, 0.22. All right, there we go. Fourth question. The board game has players roll two dice. Okay. One six-sided and one four-sided. And subtract the numbers showing on the faces. The game only looks at non-negative differences. For example, if a player rolls a 1 and a 4, the difference is 3. Here's a sample space. Sample space basically shows you the all possible outcomes. Okay, the possible equal likely outcomes of a single roll. Okay, first die you can have 1 and then 2, so the probability is, this is the probability. Okay, so here's the sample space showing the possible equally likely outcomes of a single roll. First die, which graph represents the theoretical probability distribution of the differences, whether it's A, B, or C, of the differences. Okay, so it's the difference, my bad. So if you have 6 in the first and then 1 in the second, so 6 minus 1 is 5. Similarly, let's see another, this thing, 5 minus 3, 5 minus 3 is 2. So we want a theoretical probability distribution of the differences. All right, so for 0, you see how many total do you have? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4 times 6, that is 24. You have a total of 24 possible thing. So 6 into 4, 24. And for 0, you have 1, 2, 3, 4. So favorable outcome divided by total outcome, which is 24. So that is 1 upon 6. Okay, so for 0, I should have 1 upon 6, which is not here. 0, 4 upon 6, 4 upon 24, 1 upon 6. Okay, so everything is in 24. So I need 6, for 0, I need 4 upon 24. So here C correctly depicts it, and also B, and also A. So A, B, C, no, B doesn't, because we don't have the difference 0 included here. So B cross out. We don't want this. For because we have a different 0. Why do you eliminate 0 at all? So B is not what we want. Now for the first one, they only show up to 3, but we have difference up until 5. So C is the perfect thing, is the thing that we want. All right, so next question. Contestants on a game show spin a wheel with 24 equally sized segments. Most of those segments show different prize amounts, but 2 of them are labeled bankrupt. All right. Suppose that a contestant is going to spin the wheel twice in a row. Here are some events and their meaning. B1, the first spin lands on bankrupt. B2 is the second spin lands on bankrupt. The first spin does not land on bankrupt, so this is the notation. The second pin does not land on bankrupt, BC2. Okay, consider probability, this thing. So probability of this thing. What does this thing represent in this context? Well, the probability, you have the probability that the first pin does not land on bankrupt, this is thing, and the second pin does not land on bankrupt. This is what it is representing. So the probability that first thing lands on given, no. The probability that both spin lands on bankrupt, yeah. lands on bankrupt, neither lands on bankrupt. Does not land on bankrupt. So A is our answer. Okay, so we have a pick three lottery game involves drawing three numbered balls from separate beans. So imagine you have three separate beans or like something like this, bean one, bean two, and there are balls in it where we have 0 to 9 numbers. So a ball with number 0, a ball with number 1, a ball with number 9, and like from 1 to 9, you've got 10 balls. So there are 1,000 possible selections in total. Players can choose to play a straight bet where the player wins if they choose all three digits in the correct order. Okay. There are 1,000 possible selections. The probability that the probability a player wins a straight bet is 1 upon 1,000, because probability that you select the correct ball on a specific one single bag, or they have called it bins, whatever, is 1 upon 10, and the probability that you select all of them correctly is 1 upon 10 into 1 upon 10 into 1 upon 10, and this is how you got 1 upon 1,000. Okay, the lottery pays 400 on a successful $1 straight bet. So you have to pay $1 to get into the game, and if you win it, you get 400 in return. So that gives you a net gain of 399. So let X represents a player's net gain on a $1 straight bet. Calculate the expected net gain, EX. The expected net gain can be negative. So net gain is what your profit that you can expected net gain. So what is the cost? It is 1. So for sure you have to subtract it with -1. But what is the outcome that you are getting? You're getting $400, but you have a probability for getting that is 1 upon 1,000. So the near expected value is this thing. And your net gain, this is where you gain minus what you invest. So 400 divided by 1,000, 400 divided by 1,000 minus 1 is your expected net gain, which is negative 0.6. Okay, negative 0.6. Let's see. There we go. Ying owns a company that gives city tours on a bus. Over the span of a few years, she kept track of how many customers were no shows, which means that they paid for it but they didn't appear on each tour. People who bought a ticket but they didn't show up for their tour. The table below is a probability distribution Ying created where X represents the number of no shows given on a given tour. So the probability that you have X has 0 is 0.03, and for 1, so on and so forth. Which graph correctly displays the probability distribution table? So for 0, I should have 0.314. So 0, 0. No, it is below, as you can see, it's below 3. It should be above 3. So cross out. It's good with B, and this is something above 3.5, and this is not the case here. So I don't have to look anything else. B. All right. So Roulette is a casino game that involves players betting on where a ball will land on a spinning wheel. Okay. An American roulette, if I'm not mispronouncing, wheel has 38 numbered slots. 38 numbered slots. Half of the slots from 1 to 36 are red, and other half are black. Slots 0 and 00 are both green. Okay. Half of the slots from 1 to 36 are red, and the other half are black. Okay, I understand. Let me give a visual to increase the understanding. So here is this spinning wheel. Sorry about that. So here is our spinning thing. Where do you draw? Here. And you have got 38 numbered. Okay, so let's use black. Anyway, so if we have from 1 to 36, so let's say there are 38 of these, and 0 and 00 are both green. Half of the slots from 1 to 36 are red. And so we have in total 36 divided by 2. 36 divided by 2. We have 18 red, 18 black, and the remaining are green. So we have 18 red. We have uh, we have 18 black, and we have 2 green. Okay. Suppose that a player bets $1 on a single slot. If the ball lands in their slot, the player gets their initial $1 back plus a payout of $35. If the ball doesn't land in their slot, they lose their $1 bet. Let x equals to be the player's net gain from a $1 bet on a single slot. Here's the probability distribution of x. So if you win, you get 35, and that is you have a probability of 1 of 38, and if you lose, you get negative 1, 37 by 38. Find the expected value of a player's net gain on a $1 bet on a single slot. You may round your answer to nearest thousand, which means 2 decimal places. 2 decimal places. So here, this is the ones, this is tens, this is 100. Okay. 2 decimal places, and to find the expected value of a player's net gain on a. So expected value is just the mean actually. So you get 35 into 1 upon 38. 35 into 1 upon 38. Okay. And then plus that is negative 1 into 37 by 38. So 37 by 38 into negative 1. All right. So our expected value in 2 decimal places is 0.05. Negative 0.05. Negative 0.05. Negative in 2 decimal places is 0, negative 0.05. 35 if you win, you get your $1 back plus a payout of 35. So your gain is this thing, 37 by 38 into negative 1 and 35. So on a $1 on a single slot, negative 0.05. Oh, on 2 decimal places, right. Nearest thousand, not 100. Oh, everything is fine. So ones, this is tens, this is 100, and this is thousands. Okay, there we go. So in decimal places, you don't have any like ones in the decimal thing. So let's say this is 7.273, and this was maybe 27. This is ones, this is tens, we know, and this is also tens. So ones is surrounded by tens, and then 100, and then 1000. So this thing is goes to 0.053. All right, 0.053. There we go. Gotta be careful when reading the question. Sometimes silly mistake happens. um, 50 people were surveyed about their preference between chocolate and vanilla cake. Okay, 50 people were surveyed about their preference, whether they like vanilla or chocolate. The following two way table displays data for the sample of people who responded to the survey. Okay, in this sample. Are the events female and prefers chocolate mutually exclusive? Which means if you are a female, you cannot prefer chocolate. Is this the case? No. We have a data where the respondent were a female and they preferred chocolate. So this cannot be mutually exclusive. Mutually exclusive refers to the event where if you have one, you cannot have the other. Find the probability that the randomly selected person from this sample is female or prefers chocolate. So we need, what is the probability for female or prefers chocolate? The probability that you are a female or prefer chocolate is, first of all, I need to find the probability that you are a female. So which is total female here 22 divided by 50, and then I have to find the probability of one who prefers chocolate, so C, which is 33 upon 50. Now here's the thing, we need to subtract probability of female and chocolate, which is female and chocolate. So female prefers chocolate is 15 divided by 50. Why? If you imagine two sets, okay, like this, one represents the female, another one represents the chocolate. So you want or, which means you want a union, okay? A union means shading these, this shaded portion, right? So if you want this, while, you know, if you want this portion and you find the probability of female, then what do we get? You end up calculating this portion. And then when you calculate C independently, you have an overlap. You calculate, this portion twice. Why are you taking this portion, union portion, twice? That's why you have to subtract one of that value from the summation of these two values. So that's why the answer would be 22 upon 50, 22 divided by 50, plus 33 divided by 50, minus 15 divided by 50, 0.8. Let's see. There we go.